Hi everybody, I'm quite excited to be there to talk to you about some choices we've made to use FHIR as a data model for a persistence layer. I'm also a bit stressed, so I hope it will not pose any problem. I'm Florian. I'm a software developer doing freelance in healthcare companies or hospitals. And I'm giving a hand to Harkan, which uses interoperability to build data lakes in hospitals using open source softwares to give back to hospitals their sovereignty on their data and their data lakes. To give a bit more context about the situation, how I see things in hospitals is that we have services and they are all connected using customs connectors, and when you are a new actor, you have to plug into all this stuff and it's very hard. So with FHIR, you know that it helps a lot. You don't have anymore to understand every models. Of course, this is not perfect. You always have some difference to handle, but it's not the same work to be able to implement your software in the hospital. But from my point of view, we are duplicating a lot the data inside the hospital because each of the softwares have its own database, and we are missing a sort of source of truth in the hospital. And I think it's a problem. So I believe that we should have a central source of truth, a sort of central database, and I've the faith that we could do that in FHIR. So how could we architecture this database, this central database? The classical architecture is to have, a model, a schema, which is often custom, sometimes using standards like OMOP or OpenEHR, but most of the time homemade. And we put on top of it a FHIR API. But when you have to do certain some operations, special operations, it's a good point to be able to access the under layered model, and that's a problem for users because they have two models, in fact, which are different, and they have to understand both of the models and which type of operation need an access to the underlayered database. The example is the federated learning approach. Walter here done a previous talk about it, but I will cover this in some slides. To talk about it, we can come from the centralized approach, the classical one, where you have to get all the data inside, for example, an algorithm inside a server executing an algorithm in the cloud. You compute the results in this server, and you send back the results to the hospitals. You understand that it's quite a big problem from a privacy and security point of view to get all this data, and hospitals are not really okay with that, and for good reasons. And so the federated learning approach is to send the algorithm to the hospitals to compute intermediate results in the hospitals and to merge them to get the big purpose, to get the final result. To do that, you have to get a good access to the database in each hospital for your algorithm. And it's quite difficult to do machine learning with big data needs on top of a REST API. It's not very performant. So gain a low-level access like that is very useful. But if we can use the same model as the FHIR API, we are still all talking the same language, and it's a good point. So it's a bit like the idea of getting one schema to rule them all. And with that schema, we can imagine multiple types of access on top of the data, but always sharing the same model. And everybody is using the same language. Which type of database could we use to store this model, this FHIR model? We could use the relational database, but as Firebase and Pavel analyze in an article I give in the slides, to handle FHIR model totally in a relational database, you need more than thousands of tables, and it gives you many constraints to handle joins when you are querying the database, and CRUD starts to be very complicated when you have to address a lot of tables in the same time. So from the Firebase point of view, they decided to keep the relational database, but put the model, the data using the FHIR model, inside a JSON-B in a single column of the database. And we decided to explore another way, which is to use document-based database. It's a type of database which is more close to the graph approach that FHIR have. We also could use a graph-oriented database, but I think the graph database are not as mature as we need for hospitals production, for production in hospitals. And the document-based database is a good solution because it's mature and it fits very well with the FHIR model. So in practice, it's MongoDB we choose for that. And it allows us to have scalability, and it's sufficiently versatile to handle the various ways that FHIR works. In practice, it's give us the advantage to use the FHIR JSON schema, the global one with all the resources defined in the specification, as validator to validate every single operation we made on the database. So this is quite a small extract of the FHIR schema, and we have the patient here with an ID referencing a definition of what is an ID, and the ID is a low-level type, and have everything here to explain what is an ID and what is not an ID. And this type of schema is almost exactly the same that MongoDB is taking as validator. So it was very easy to use the FHIR JSON schema as a MongoDB validator. We've made, yes? The question is, how do we do adjustments on the FHIR schema? I will talk about that just after. The answer is yes, but not so big. We've compared a bit Firestore and Firebase, not just to be sure that we are we were not going in the wall. Is the thing we are doing is wrong or not? And the performance are quite the same. To be sure that one or the other is better than the other one, we have to perform more benchmark because this one was just on some computers, laptops, and so this is just really a naive benchmark. If we go deep in the code, the usage is like that, and we are using the Mongo client, and we initialize the client with the JSON schema. So this is not a Mongo server side or Mongo database side validation we are doing. It's client side because this is how Mongo is working. So it's not exactly the same than in a relational database where the schema constraints are on the column, and this is the database engine who is doing the validation. Here is the client, so we have to ensure that all the clients using the database for writing are validating the data with the schema. This is one of the points about validation. And going inside, we are using the FHIR schema, and we are extracting some information in it. So the definitions, which are the things I've shown previously for the patient or the ID. We are extracting the various resources which are in the schema, which has this shape, and we are resolving all the things. What is resolving? We are recursively going inside the resources to dereference, so to inject instead of the reference, the real definitions. For example, in a patient, we replace the ref ID by the real ID definition. So we have a depth maximum to avoid cyclic references. And about your question, to ensure compatibility with Mongo JSON format, we have little adjustments because Mongo used the draft 4 of JSON schemas. For example, there is no const allowed by Mongo, and there is const in FHIR schema. It was an easy thing to handle because it just replaced const by enum, but maybe it could be harder if it was other drafts. And we had to add an ID field. We also inherit the resource list in the FHIR schema because this is a resource which handles all other resources. So it's a bit redundant, and we are injecting the whole FHIR schema inside a resource, so it's a bit big. So it's over for me. It was a community track, so I had 20 minutes, and I've planned my presentation for that. But we can discuss about the subject more wider. The next steps are to handle the FHIR version change, because when you talk to people from FHIR community about using FHIR as a data model, this is the first thing which comes, that okay, but you will have to handle the version change in FHIR, so your model will have to move, or you will have to expose the new FHIR API version on top of your older schema, older model. So this is a point to handle, really. It's maybe not so hard because FHIR publish mappings to move from R3 to R4 or R4 to R5. So it should be okay. The next step is also to handle FHIR profiles, and not only the main JSON schema from FHIR, to be able to validate small parts, sub-specification finally for real case. Maybe we could also use structure definition or graph definition to validate more complicated operation done on the database. And the point of the slicing seems to be quite hard in profiles to handle. So we are expecting problems on that field, but we will give you returns about it on the chat probably. So thank you very much. Feel free to ask questions. I'm here to answer to you. Yeah?
On our original FHIR server Spark, we used Mongo as a backend, and we found out that the search interface of FHIR cannot be fully handled by the Mongo query language on JSON.
Sorry, I'm not sure to...
sorry, the FHIR search has a lot of complex searches, and we found out that if you store the JSON of the resource as is in Mongo, then the Mongo search operations cannot fully handle the FHIR search operations. Did you encounter the same already, or?
We didn't really encounter the same because we are still working on building the FHIR API on top of it. So we are far from the 90 or 100% of FHIR coverage. So thank you for your pointing that. The approach is maybe also to make search using Elasticsearch. So maybe it helps on that. That's the only thing I know. Good point. Yes?
Do you transform your data to another format for machine learning, like Parquet?
The question is, do we transform the data to other formats for machine learning? It depends. In your case, I don't remember. I'm not the one doing the federated learning. I don't know if you know the answer. It's quite common to do that. So I was very interested by the presentation yesterday by someone from IBM and working on Parquet. So if you, when the videos will be published, I suggest you to look this presentation. It's how to store the FHIR resources as Parquet. So very interesting also to perform Spark on it after that.
Okay, something you can also see that Google this transformation from Proto to TensorFlow inputs, and well, it seems to work. So it's possible.
Any other questions? Thank you, everybody.